Hello everyone, this side Manisha Mishra, Assistant Professor in Mathematics, Applied Science Department at St. Andrews Institute of Technology and Management, Gurgaon. This college is affiliated to Meher Siddhanand University. So today I will discuss the topic of Principle of Mathematical Induction. And this will be your unit 4th for the Mathematical Foundation of Computer Science, that means MFCS subject, and code is BCA 108, right? So the topic principle of mathematical, you guys have already studied in your 11th 12th standard, so same as in you have studied in your 12th standard, same method is also here. So this topic is coming under your number theory, uh, right? So principle of mathematical induction. Let Pn be a given statement involving the natural number n. That means P is a your statement and n is your natural number. So first statement is the statement is true for n is equal to 1. It means P1 is true. That means first we will prove for the n is equal to 1. That means for first natural number. If it means P1 is true, if P1 is true, then second statement, if this statement is true for n is equal to k, then we will put n is equal to k, where k is some positive integer. Then this statement is also true for n is equal to k plus 1. That means if it is true for n is equal to k, then we will check for n is equal to k plus 1. And if this is true for n is equal to k plus 1, then we can say that in the pk or pn is true for all n. That means it will be true for all our natural numbers. Right? Now, there is an example here. This is a very easy example. 1 plus 3 plus 5 and so on, 2n minus 1 is equal to n square. So we need to prove this. This is true for all natural numbers or not, and by using principle of mathematical induction. So let the given statement Pn be defined as, so your statement is always be Pn. So Pn you are writing 1 plus 3 plus 5 plus and so on plus 2n minus 1 is equal to n square. So this is your Pn for n belongs to n. Now first statement is, the statement is true for n is equal to 1. So just put here n is equal to 1. So you will get in left hand side 1 and in right hand side also 1. That means left hand side is equal to right hand side. That means we can say that P1 is true for n is equal to 1, right? Yeah, Pn is true for n is equal to 1. Since P1 we are getting 1 is equal to 1 square, so this is true. Now second statement, if the statement is true for n is equal to k, that means we will put n is equal to k. So just write here. So we are assuming that pk is true for some k belongs to n. It means pk says that 1 plus 3 plus 5 and so on, 2k minus 1 is equal to k square. Just replacing n by k here. Now another task. Third statement is now to prove that n is equal to k plus 1. It means p of k plus 1 is true. So if pk plus 1 is true for k plus 1, then we can say pk is true for all integers for k, and pn is true. So just put here sorry, just look at here, 1 plus 3 plus 5 plus and so on, 2k minus 1 is equal to k square. This is your kth for the kth term. Now to prove that pk plus 1 is true, we have 1 plus 3 plus 5 plus and so on, 2k minus 1. So this is your this term 2k minus 1 plus 1 plus 3 plus 5 plus and so on, 2k minus 1. So this is your 2k minus 1 plus 1 plus 3 plus 5 plus and so on, 2k minus 1. So this is your 2k minus 1 plus 1 plus 3 plus 5 plus and so on, 2k minus 1. So this is your 2k minus 1 plus 1 plus 3 plus 5 plus and so on, 2k minus 1. So this is your 2k minus 1 plus 1 plus 3 plus 5 plus and so on, 2k minus 1. So this is your 2k minus 1 plus 1 plus 3 plus 5 plus and so on, 2k minus 1. So this is your 2k minus 1 plus 1 plus 3 plus 5 plus and so on, 2k minus 1. So this is your 2k minus 1 plus 1 plus 3 plus 5 plus and so on, 2k minus 1. So this is your 2k minus 1 plus 1 plus 3 plus 5 plus and so on, 2k minus 1. So this is your 2k minus 1 plus 1 plus 3 plus 5 plus and so on, 2k minus 1. So this is your 2k minus we are proving for n is equal to k plus 1. So that means in your given statement 2n minus 1 here, and you are replacing n is equal to k n by k plus 1. So just write here k plus 1. So 2k plus 2 minus 1. So you will get 2k plus 1, this term. And before this term, there is a term 2k minus 1 here. So just always remember that if you are proof for k plus 1, right, so n will be replaced by k plus 1, and you will put n as k plus 1, then you will get your last term. But before the last term there is another one term, and that value 1 plus 3 plus 5 plus and so on 2k minus 1. So till 2k minus 1, we have a value. So we value is k square. So we can write here k square plus 2k plus 1. And this is your k plus 1 whole square. A square plus b square plus 2ab. So we can write here k plus 1 whole square. So now check this is true or not. Our statement is Pn is equal to 1 plus 3 plus 5 and so on to n minus 1 is equal to n square. That means n is here, n square is here. So k plus 1 is here, so k plus 1 whole square is here. Thus pk plus 1 is true whenever pk is true. Hence, by the principle of mathematical induction, Pn is true for n belongs to n, means for all natural numbers. This term can be this term 1 plus 3 plus 5 plus and so on 2k minus 1 plus 2k plus 1. That means before 2k plus 1 there is another term 2k minus 1, right? So you will write this value as k square and your statement is complete. Now there is another example here. An example is summation t is equal to 1 to n minus 1, t plus 1 is equal to n minus 1 n plus 1 upon 3 for all natural numbers n is greater or equal to 2. So let the given statement Pn be given as. So this we have to prove this one by the principle of mathematical induction. So let the given statement Pn be given as Pn is equal to summation t is equal to 1 to n minus 1 t plus 1 is equal to n minus 1 n plus 1 upon 3. Right? For all natural number n is greater or equal to 2. Now we observe that n is given, condition is given, n is greater or equal to 2. That means we will not put here n is equal to 1 because this statement is true for n is greater or equal to 2. So we will put here n is equal to 2 because the starting number is 2. So when put p is equal to 2, that means summation t is equal to 1 to 2 minus 1, and t plus 1 is equal to summation t is equal to 1 to 1. 1 to 1 means 2 minus 1, 1. That means only one term will be here, t plus 1. And we are having t is equal to 1 here. So 1 into 2. So you can write and now basically we have to write this term as our given statement term. So we can write 1 into 2 multiply by 3 divided by 3. So 1 in, you can write 2 minus 1, and 3 you can write 2 plus 1, and 2 as it is upon 3. Just look at here and try to understand what we are doing here. The given statement is starting from n is greater or equal to 2. So just put n is equal to 2 here, and your Pn is given this one. If you will put n is equal to 2 here, then your statement is t is equal to 1 to 1. That means t, you will put only 1 here. After putting 1 here, then you will get 1 into 2. 1 into 2, and this 1 into 2 is not in the form of this one. So we have to convert our 1 into 2 in this form. So you can write n is equal to 2. Just put, you did put n is equal to 2 here. So 1 into 2 and divided by 3 and multiply by 3. So 2 into 2 minus 1 and 2 plus 1 upon 3. So this statement and this statement both are almost same, because if n is equal to 2 you are taking, so you will get this one into this one, right? So Pn is true for n is equal to 2. Now assume that Pn is true for n is equal to k. So for n is equal to k, you will write in place of n k. So just replaced n by k. So k minus 1, k plus 1 upon 3. So this statement is also true for n is equal to k, and this is very easy. Now next one, to prove that pk plus 1 is true. So for the pk plus 1, you are replacing n is equal to k plus 1. So t is equal to summation, your statement will be t is equal to 1 to n is replaced by k plus 1. So k plus 1 minus 1. So t plus 1 is equal to summation t is equal to 1 to k t plus 1. Right? Now you can write your equation t is equal to 1 to k as t is equal to 1 to k minus 1 t plus 1, plus last term will be your, this is your t is equal to 1 to k minus 1, and t is going from 1 to k. Just try to understand this term. This term t is summation is t is moving from 1 to k. So 1 when that means if you will put 1 here, then you will get 1 plus 1, plus second term will be your 2 plus 1, plus 3 plus 1. So last term will be your k plus 1. So this is your last term, k plus 1. But before last term, you are getting a term here, k minus 1 and k. Before kk plus 1, you have a term which is k minus 1 and k, means k minus 1 term. So some you can write k minus 1 term as t is equal to 1 to summation k minus 1 t plus 1, and the value of this term we have k minus 1 k plus 1 upon 3 plus k plus 1. So just solve this term and you will get k plus 1, k and k plus 2. So just check this term and this term, that means this term is not same. So you have to convert your term as above term. So k plus 1 minus 1 and k plus 1 plus 1 means 2. You can write 1 plus 1 and k plus 1 this will here, and k just add and subtract 1 there will be no difference upon 3. So thus pk plus 1 is true whenever pk is true. Hence by the principle of mathematical induction, Pn is true for all natural number which is starting from n is greater or equal to 2. This term can be this term can be rises some difficult to you to understand. Let's just try to understand that our last term is this one, and where it is coming from. If you will put t is equal to k here, then you will get k plus 1. So k plus 1 will be your last term, and before last term you also got a term which is moving t is equal to 1 to k minus 1. So just put t is equal to k minus 1 here. So k minus 1 plus 1, that means k minus 1. So before and t is equal to 1 to k minus 1 t plus 1. We have our value this, and this is your numerical term. Just solve this term, then you will get this term, right? Now, next, I will discuss some question papers, old question papers of your. Just wait a minute. Right. So this is your old question papers, and this is your MDU, Maths Dayanand University, Rohtak, and this paper is April 2018. Right. So there is a look here. Just look at here. First question. So first attempt 5 questions in all. That means you will attempt 5 questions. Question first is compulsory. That means you cannot leave our your question first. So you have to attempt. and attempt 4 questions more by selecting one question from each unit. That means आपको हर एक यूनिट से एक क्वेश्चन अटेम्प्ट करना है और टोटल क्वेश्चन आपके 5 होंगे, राइट? एंड ऑल क्वेश्चंस कैरी इक्वल मार्क्स. So first question is, if the mean of this one is 12 and then find the value of x. So this type of question I have already told you. Then how will you solve this question? So mean is given, that means x bar is given, and x bar is equal to summation xy upon n. So just find total n, 1 2 3 4 5, and x1 x2 x3 x4 x5. So just write all these values divided by 5, and mean is given 12, multiply by cross multiplication, and just you will get your x. Now second question is, find the standard deviation of this one. Right? So I am just discussing the part of mathematics here, right? So standard deviation formula you have already known. So just find square root of x minus x bar whole square upon n. So you need to calculate first x bar here, then you will calculate a second column x minus x bar, third column x minus x bar whole square, and just find summation of these terms. Total n is given 5. Just put all these values in the formula, then you will get your answer. Now this question, G question and H question is coming is your 4th unit question. So I am just I am just starting your I did start your 4th unit. So only one topic just discussed, and these topic I will discuss in our further videos. So just look at unit first question. So second A, find the missing frequency in the following distribution table, it being given that the mean of the distribution is 50. So I have already told you you this question, you know, and I think I provided you the solution of this question. So just learn to find how to find the frequency, missing frequencies. Now second question is, find the median of the following frequency distribution. So I think I have already provide you a solution of these questions, but remember one thing, that unit 1 contains second question and third question. So you will attempt only one of these. It means if you are attempting your second question, so you have to done your second A and second B. You cannot solve that second A you have done and third A. So that is wrong, right? So just attempt only one question. If you are attempting second, then complete second. If you are attempting third, then complete third. That means third A, third B, right? Find the regression line of y on x for the following data. And regression line I have told you, and this is your Carl Pearson coefficient of correlation. So if these of two questions if I did not discuss with you, so I will do and provide you a solution of these questions, right? So fourth, fifth, sixth, and seventh question are coming from your second unit and fourth unit. These are computer units. So now 8th and 9th question, both of the question belongs to unit 4. So these questions I will discuss in our further videos, because when I first we have to complete our solution, sorry, syllabus, then further discussion. Now there is your another paper, and this paper is your April 2018, right? This is your April 2018, this one to 2015 course paper, right? So 2015 paper, wait just a minute. Okay, right. Now May 2015. So define measure of dispersion, list the method of measure of dispersion. So definition, you know the definition of measure of dispersion, measure of variation, and list the method of measure of dispersion. So I have already told you what is the list to measure the measure of variation, right? Standard deviation, range, quartile deviation, mean deviation. So these are the lists to measure the measure of variation. Now Second question is find the median for the series, this one. So you can calculate median for this series. So first arrange this series into ascending order या फिर descending order में. So just and the total n is 1 2 3 4 5 6 7 8 n is equal to 8. So n by 2 plus 1 term. So just 8 by 2 plus 1, so will be your fifth term. So fifth term, after arranging in ascending order or descending order, then you will get your fifth term. So write your answer, right? Now, second, find mean marks obtained by the student. So this is your 100 is your total number of frequency. Marks is given. So first column is given, second column is given, and third you will find your middle value. That means 0 plus 10 divided by 2, 10 plus 20 divided by 2, 20 plus 30 divided by 2, and so on, 40 plus 50 divided by 2. That will be your x, means variable. Now, third, fourth column will be your fourth column is nothing but f into x. So I find f into x and summation f into x. Just put all the value. If you are using the formula deviation, so write d is equal to x minus a. So first choose assumed mean, then calculate d is equal to x minus a. And second B question is standard deviation questions. So just try to solve these questions. If you guys have any problem in this question, so just contact me, and I will provide you solution of these questions. And there is another question. This is question is related to coefficient of correlation, and this type of question I have already discussed in our previous session, previous video. So just check that video, and you will and solve this question. The same apply same method, right? So don't worry, I will share the solution of these questions in our next video. Now there is an exercise here, and this is our exercise. So solve this exercise, and these types of question always we ask in a semester exam. So solve this exercise, and I will share solution of this exercise also, but further in further videos, right? So just learn all these topics. Thank you.